Stop looking at the night sky like it is a painting. It is not a painting. It is a crime scene. You are looking at the aftermath of the most violent event in history, but you are visualizing it completely wrong. You think you know the story. You picture the Big Bang as a grenade going off in a dark, empty room. You imagine a silent void, and then suddenly, flash, matter flies out like shrapnel, rushing into the empty space, creating galaxies as it goes. This is the picture in your head. This is the picture in the textbooks. And it is a lie. There was no center. There was no empty space for the explosion to happen in. The Big Bang did not happen at a specific point in space. The Big Bang happened to space. It happened everywhere, all at once. This is the concept that breaks the human mind, because we are creatures of geometry, built to understand containers and contents. We think the universe is the content and space is the container. But general relativity tells us that the container itself is the thing that exploded. Imagine an infinite loaf of raisin bread. Not a loaf you can hold in your hands, but a loaf that goes on forever in every direction. The dough is space-time. The raisins are galaxies. You are sitting on one raisin. Now, put the loaf in the oven. The dough begins to rise. It expands. Look at your neighbor raisin. It is moving away from you. Look at a raisin a mile away. It's moving away from you even faster. But here is the trick. The raisins aren't actually moving through the dough. They are sitting still. It is the dough between them that is being created. There is more dough now than there was a second ago. This is what is happening to our universe right now. Galaxies are not flying through space like rockets. Space is being manufactured between them. The vacuum is stretching. Every second there is literally more nowhere than there was before. This means that from any raisin, from any galaxy, it looks like you are the center of the explosion. But if everyone is the center, then no one is. There is no edge. There is only the stretching. How do we know this isn't just a mathematical fever dream? Because we can see the skid marks. Go back to the 1920s, to Mount Wilson Observatory. Edwin Hubble is sitting in the cold dark, peering through the telescope. He splits the light from distant nebulae into a rainbow, a spectrum, and he sees something haunting. The barcodes of reality, the absorption lines of elements like hydrogen, are shifted toward the red end of the spectrum. Redshift. You know this effect. You hear a train whistle drop in pitch as it passes you. The sound waves get stretched as the source moves away. Hubble realized light does the same thing. The light from distant galaxies was being stretched, made redder, because the space it was traveling through was expanding. The wave was being pulled apart by the road it was driving on. And the farther the galaxy, the faster it was running. This was the first smoking gun. The universe is not static. It is a film reel playing forward, and the actors are getting smaller. But if the film is playing forward, we can run it backward. This is where the terror sets in. If everything is moving apart now, that means yesterday it was closer. 1 billion years ago it was cramped. 13.8 billion years ago, everything. Every star, every planet, every atom in your fingernail, every photon of light was crushed into a single point. Infinite density. Infinite heat. The singularity. But wait. The Big Bang Theory, the actual scientific model, doesn't start at time zero. It starts a fraction of a second after. It describes the expansion, the cooling, the evolution. It describes the fire. It does not describe the match. We actually have a photograph of this fire. But it's not a picture you see with your eyes. It's a picture you hear. In 1965, Arno Penzias and Robert Wilson were building a radio antenna in New Jersey. They wanted to listen to the silence of space. But they couldn't get silence. There was a hiss, a persistent, annoying microwave static coming from every direction at once. They thought it was pigeon poop on the antenna. They scrubbed it. They shooed the pigeons. The hiss remained. That hiss wasn't bird droppings. It was the scream of the universe's birth. They had accidentally discovered the cosmic microwave background, CMB. This is the afterglow of the Big Bang. 380,000 years after the beginning, the universe cooled enough for atoms to form, and light was finally able to travel freely. That light has been traveling for 13 billion years, stretched by the expansion of space until it turned from blinding white light into invisible microwaves. If you turn on an old analog TV to a dead channel, about 1% of that static snow is the cosmic microwave background. You are watching the ashes of creation dancing on your screen. But the story gets darker. We need to talk about the War of the First Second. This is the part of the story that should keep you awake at night. Rewind the clock. Go back to when the universe was 1 second old. The temperature is 10 billion degrees. At this heat, atoms cannot exist. Nuclei cannot exist. Even protons and neutrons are boiling apart. The universe is a soup of quarks and gluons. Here lies the greatest mystery of all. EMC2. Energy can turn into matter. But the equation has a dark twin. When you create matter from pure energy, you must also create antimatter. For every electron, you get a positron. For every proton, you get an antiproton. They are perfect mirror images, and when they touch, they annihilate. They turn back into a pure flash of gamma radiation. So, at the beginning, the universe was a slaughterhouse. Matter and antimatter were being created constantly from the energy of the vacuum and instantly destroying each other. Create. Destroy. Create. Destroy. A perfect balance. And if that balance had held, the universe today would be nothing but light. No stars. No planets. No you. Just a cold, empty bath of photons. But something happened. A glitch in the matrix. A violation of symmetry. For every billion particles of antimatter, the universe created 1,000,001,000 particles of matter. A tiny, almost statistically insignificant imbalance. A rounding error in the code of creation. Then the universe cooled. The energy dropped. Creation stopped. But the destruction continued. The billion antimatter particles found their billion matter partners and annihilated. Boom. They were gone. All that was left was the +1. The survivor. Look at your hand. Look at the chair. Look at the stars. All of it, every single atom in the visible universe, is just a leftover shrapnel from that great annihilation. We are the rounding error. We are the tiny fraction of matter that survived the suicide pact of the early universe. You are made of the winners of the greatest war in history. Does that make you feel lucky? Or does it make you feel lonely? And we are not just travelers in space. We are travelers in time. And this is where the story turns from a history lesson into a horror story. You take time for granted. You think time is just a river that flows from the past to the future. But why? Why can you remember yesterday, but you cannot remember tomorrow? The laws of physics do not care about past and future. If you look at Newton's laws or Einstein's relativity, they work perfectly fine in reverse. So, where does the arrow of time come from? It comes from entropy. Imagine a library. Books are sorted alphabetically. That is order. Low entropy. Now throw a grenade into the library. The books fly everywhere. Pages are torn. That is disorder. High entropy. There is only one way for the library to be perfectly ordered. There are billions of trillions of ways for it to be a mess. So, statistically, If you wait long enough, things will always move from order to chaos. Time is the increase of disorder. The feeling of time passing is just your brain recording the slow disintegration of the universe. This implies something terrifying about the beginning. If entropy is always increasing, that means yesterday entropy was lower. And if you trace this all the way back to the moment of the Big Bang, you reach a conclusion that made the physicist Roger Penrose lose sleep. For the universe to look the way it does today, the initial state of the Big Bang had to be incredibly, impossibly ordered. The precision required to set up that initial state is 1 part in 10 to the power of 10 to the power of 123. That number is so big that if you wrote a 0 on every atom in the universe, you wouldn't even have written down the fraction of the number. This is the past hypothesis. The universe started in a state of exquisite, razor-sharp perfection. Why? We don't know. We have no idea that it is the greatest statistical fluke in existence. If the Creator had thrown a dart at the board of possible universes, hitting our universe would be like hitting a single specific atom in the entire Milky Way galaxy from 1 billion light years away. Blindfolded. So, when you look at the expansion, realize that you are surfing on a wave of disorder that started with a miracle of order. And what lies at the end of that river? Let's talk about the future. Not the next 1,000 years. The deep time. Right now, we live in the stelliferous era. The era of stars. It is the only time in the universe's history where life is easy. But the stars are gas tanks and the gauge is dropping. Every second, the sun burns 600 million tons of hydrogen. It cannot last forever. In about 5 billion years, the sun will swell into a red giant. It will swallow Mercury and Venus. It will boil the oceans off the earth. The mountains will melt into lava. And then, it will collapse into a white dwarf, a glowing ember the size of the earth, slowly cooling in the dark. This will happen to every star. One by one, the lights will go out. In about 100 trillion years, the last star will serve its last photon. The universe will go black. If you were alive then, looking up, you would see nothing. No Milky Way, no Andromeda. Just the cold, dead infrared heat of dying embers. But it gets worse. Protons, the building blocks of your body, might not be immortal. Many grand unified theories predict that protons eventually decay. If this is true, then matter itself is temporary. In about 10 to the power of 34 years, every atom in the universe will dissolve. The stars, the planets, the dust, your bones, it will all evaporate into a mist of electrons and photons. The concept of solid object will cease to exist. The universe will be empty, silent, cold. Just a bath of radiation stretching out into the infinite void. This is the heat death, the dark era. Nothing changes anymore because entropy hits the maximum. Time ceases to have meaning because nothing happens to mark its passage. This is the price we pay for the Big Bang. But there is a twist ending that nobody saw coming. For decades, we assumed the expansion of the universe was slowing down. Gravity pulls things together, so the mutual gravity of all the galaxies should be breaking the expansion. We thought the universe would eventually stop expanding and maybe collapse back in on itself. The Big Crunch. But in 1998, we looked at distant supernovae to measure the deceleration. We wanted to see how much the car was slowing down. Instead, we found that the foot was on the gas. The universe is not slowing down. It is speeding up. It is accelerating. Something is pushing the galaxies apart faster and faster every second. We don't know what it is. We call it dark energy. It makes up 68% of the energy budget of the universe. It is a repulsive force inherent to space itself. The more space you have, the more dark energy you have. It is a runaway feedback loop. This means the galaxies will eventually be moving away from us faster than the speed of light. They will cross the cosmic horizon and vanish. First, the distant clusters. Then, the nearby galaxies. Future civilizations, billions of years from now, will look up at the night sky and see nothing. Blackness. They will think they're alone in a static, empty island universe. They will have no evidence of the Big Bang. The light will have redshifted into oblivion. The expansion will have erased the history. We are living in a privileged time. We are the only ones who will ever know the truth. We are living in the brief window of time where the universe is readable. So, where does this leave you? You are standing on a speck of dust, floating in a sunbeam, surrounded by a hostile void that wants to freeze you, burn you, or dissolve your atoms. You are a temporary fluctuation in the entropy of the cosmos. You are a ghost made of stardust, capable of understanding your own extinction. Does this make you small? No. It makes you precious. It makes this moment infinite. Because if the universe is destined for the heat death, if the stars are destined to fade, then consciousness is the rarest commodity in existence. The ability to feel, to love, to wonder, to scream at the dark. That is the only light the universe has. The stars are just fusion reactors. They don't know they are shining. You know, you are the eyes of the universe. You are the way the cosmos knows itself. The universe spent billions of years building carbon. It spent billions of years evolving a brain. It fought the odds of antimatter annihilation. It dodged the gamma ray bursts. It survived the asteroid impacts, all to arrive at this specific second. At you, reading these words. You are the cutting edge of the Big Bang. You are the apex of the explosion. The universe didn't happen in the past. It is happening now, inside your skull. So don't be afraid of the complexity. Be afraid of the simplicity, because the simple answers are the lies we tell ourselves to sleep. The complex truth is the only thing that is real. Now, go look at the sky again. It's not a painting. It's a mirror. And it's looking back at you.